Good afternoon, everyone, and thank you for taking the time to meet today. My name is Kenneth Tapia, and today I will be presenting the current state of the Canyon Woodcraft Enterprise Network. The goal of this briefing is to give leadership a clear overview of how the network is designed, how the different office locations communicate with each other, and how the technologies we implemented help maintain reliability, security, and efficiency across the organization. Because this presentation is intended for an executive audience, I will keep the explanation straightforward and focus mainly on how each technology benefits the company. Let's begin with a quick overview of the network. Canyon Woodcraft operates a multi location enterprise network that connects the corporate office in Phoenix with branch offices in Austin, Denver, and Flagstaff. These locations communicate using several enterprise networking technologies, including spanning tree protocol, Ether channel, OSPF, routing, network security controls, NAT, and DHCP services. Together, these systems ensure the network remains reliable, secure, and scalable as the organization grows. First, let's look at the spanning tree protocol and Ether channel at the corporate office. Spanning tree protocol, or STP, prevents network loops in the switching environment. In simple terms, loops can occur when switches are connected in ways that allow data to circulate endlessly across the network. If that happens, it can create broadcast storms and potentially disrupt network operations. SCP solved this by identifying redundant paths and temporarily blocking them while keeping backup paths ready if a primary link fails. In this environment, we use rapid spanning tree protocol, which allows the network to recover much faster when link failures occur. Either channel is also implemented to improve performance. Either channel bundles multiple physical network links into one logical high speed connection. This increases bandwidth and provides redundancy because if one cable fails, the remaining links continue carrying traffic. Together, STP and Ether channel ensure the corporate network remains stable, efficient, and resilient. Next, we will discuss OSPF routing, which connects the Phoenix, Austin, and Denver locations. OSPF, which stands for Open Shortest Path First, is a dynamic routing protocol. Instead of manually configuring routes between every network location, routers automatically discover and share routing information with each other. In simple terms, OSPF allows the network to automatically determine the best path for data to travel between locations. At the Phoenix corporate office, which serves as a primary hub for approximately 450 endpoints, OSPF connects the network to both Austin and Denver. The Austin branch advertises its local networks automatically, allowing seamless communication with the rest of the company. The Denver branch also participates fully in OSPF so that routing updates are shared across the entire enterprise network. One of the major advantages of OSPF is that if the network topology changes, such as when a link fails, OSPF automatically recalculates routes and selects the best available path. This allows communication between locations to continue without requiring manual intervention from IT staff. Security is another critical part of the network design. Several security technologies help protect the network infrastructure and the users connected to it. Access control lists, or ACLs, function like traffic filters that determine which types of network traffic are allowed into specific parts of the network. This helps prevent unauthorized systems from accessing sensitive resources. Port security is another important protection mechanism. It limits the number of devices that can connect to a specific switch port. If an unauthorized device attempts to connect, the port can automatically shut down. DHCP snooping protects the network from rogue DHCP servers that might try to assign incorrect IP addresses to users. Together, these protections create a layered security approach, helping ensure the network remains safe and reliable. Next, we will look at network address translation, or NAT. NAT allows internal devices using private IP addresses to communicate with the internet while sharing a smaller number of public IP addresses. A simple way to think about NAT is like a corporate mailroom. All ongoing mail leaves under the company's address, but the mailroom ensures responses are delivered to the correct person internally. At the Phoenix corporate office, NAT uses port address translation, PAT, allowing hundreds of internal devices to share a single public IP address when accessing internet resources. This design supports the organization's large number of endpoints while conserving public IP addresses. At the Flagstaff branch, NAT is also configured on the edge router to allow internal systems to access the internet while remaining protected from outside threats. Another important service used throughout the network is Dynamic Host Configuration Protocol, or DHCP. DHCP automatically assigns IP addresses and other network settings to devices when they connect to the network. Without DHCP, every device would need to be manually configured by IT staff. With DHCP, computers, printers, and other devices automatically receive their network configuration the moment they connect. At the Austin branch, the router provides DHCP services for the local subnet. The Denver branch uses DHCP pools to support both IT workstations and general user devices. At the Flagstaff branch, the Edge router also provides DHCP services for branch endpoints. Overall, DHCP simplifies network administration and helps the IT team manage devices more efficiently. Finally, let's briefly connect this network design to a Christian worldview perspective. Responsible technology management reflects principles such as good stewardship, servant leadership, and ethical responsibility. From a stewardship perspective, designing reliable systems with redundancy, automation, and security ensures that the organization's technology resources are used responsibly. Servant leadership is reflected in building systems that support employees and protect their network. A secure and reliable network allows employees to focus on their tasks without worrying about downtime or security risk. Maintaining strong security practices also reflects integrity and ethical responsibility by protecting company data and user information. In conclusion, the Canyon Woodcraft Enterprise Network has been designed to support the organization through reliable connectivity, strong security protections, and scalable infrastructure. Spanning three protocols in either channel maintain a stable switching environment. OSPF routing keeps communication between offices efficient and adaptive. Security technologies such as ACLs, port security, and DHCP snooping protect the network and its users. Network address translation protects internal systems while enabling internet access, and DHCP services automate IP address management across branches. Together, These technologies create a network infrastructure that is secure, reliable, and built to support future growth. Thank you for your time today, and I appreciate the opportunity to present the current state of the Canyon Woodcraft Network.